sun. It has shed light on our homes for over 4 billion years. It will continue to do so for another 4. It's massive, almost beyond comprehension, constant yet ever-changing. Born from the swirling clouds of dust and gas, it is a giant fusion engine that drives the solar system. It seems and broils like a living thing. Loops of plasma rise up, so large that would dwarf Earth. Explosions flash from its surface, and yet the sun would also give its warmth and beauty and life. Coronal mass ejections, or CMEs, are huge clouds of plasma and magnetic fields occasionally thrown off by the sun. Scientists study them because the massive burst pose a threat to space-age technology and even power grids on the ground. Within each CME lies a kernel known as the flux rope, tightly round groups of magnetic lines that can contain and transport solar material. Astronomers have seen them as CMEs burst off of the sun, but they have been next to impossible to detect on the sun itself. New research using NASA's SDO, or Solar Dynamics Observatory, has now shown that they can be seen in just one of its cameras, which shows the very hottest material in the sun. By watching a flux rope form and ejects as its CME, the research has brought some closure to one long-standing mystery: whether a rope is formed before or during a CME eruption. It's impossible to actually see the flux ropes or any of the sun's powerful magnetic fields involved with CMEs and flares, because the fields are invisible, but scientists can map them by observing plasma trapped by these fields, which shows up as thin lines under the extreme ultraviolet light. Since Earth's atmosphere naturally filters these UV light, scientists must observe them using telescopes in space, such as NASA's SDO. So there's been relatively few detailed observations of CMEs, particularly at higher temperature. SDO images the Sun at high image and time resolution. It is also the first satellite to consistently observe light with a wavelength of 131 angstrom, which highlights plasma at temperatures around 10 million degrees. This wavelength is usually reserved for studying solar flares. But what NASA and Naval Research Laboratory scientists found is that the flux robes associated with CMEs could only be seen at this temperature. On July 19, 2012, a CME erupted from the visible edge over the limb of the Sun. Because it was on a limb, the flux robes were in profile and particularly visible. Even more important, the flux robes appeared about 7 hours earlier in the same location. The robes were visible as a line of figure eights that looked exactly the way as theorists predicted they would. This is the first direct evidence that the flux robes formed well before the coronal mass ejection. Footage of the CMEs from SOHO spacecraft confirms the presence of the flux robes. By adding footage from the Astronomers spacecraft, which is viewing the Sun from an entirely different angle, the researchers were able to create a three-dimensional picture of the flux robes. For the most part, they follow the classic figure 8 pattern previously observed and predicted by solar models. But some of these robes also had feet which extended farther away than scientists had expected. This deviation from the models is interesting and requires further studies. Besides showing proof of early flux robe formation, the study also paves the way for future flux robes and CME research by literally finding a new light to observe them in. The possibility of using flux robe formation as early warning system for CMEs means this line of research can have some very practical and far-reaching applications, and it could also help to wrap up some of the long-standing mysteries of the Sun.